Hi, Algebra 3 students. This is your first set of notes that you're going to be taking. So you need your note packet called the Transformations packet. You need that in front of you. And here is what it looks like. Okay, so this is your entire packet. It's 12 pages long, all sides, and we're going to just do the first 3 pages. So this first part is going to be Know Your Parents. So one of the things about taking notes on your own is you will need to write in what I write in. Make sure you're following along. Stop the video, try something, replay it. That's the point of these. Okay. So one of the things about Algebra 3 is you know a lot of functions and you know how to write a lot of different equations, but we're just going to go define some of the major ones that you have to know. Some will be review and some will be new. So some you know. So this first one is f of x with that weird looking symbol. That's the absolute value. So this is known as the absolute value function. And so what you should have on your note packet is the name, absolute value function, and then you need to write this equation. I've already written it for you in this slideshow, but now you need to write them on your notes. Okay, the next one. This guy, as you can see, the symbol down here, f of x, or the function of x, equals the square root of x. So this is known as the square root function. I call this one the whoosh, or the swoosh, the Nike swoosh, kind of backwards. Call that the v. I have some nicknames for him, but the real name is the square root function. Okay, so this one kind of looks like a line. It is, but this one is known as the constant function. And if you look at the equation, f of x equals c, c just stands for a number. And if we were going to go by the graph, that number looks to be about 1. So this would be f of x equals 1. What that means is that y always equals 1. No matter what x we plug in, doesn't matter. The output is always 1. Okay. Graph D is my personal favorite because this describes the coronavirus. This is how it's been growing this entire time. This is known as the exponential function. When we get to that, f of x equals ab to the x. Remember, a is the starting point and b is going to be our multiplier raised to some power. Okay, now that takes care of the first 4 graphs. Let's take a look at the next 4 graphs. Oh, I forgot. Sorry about that, guys. I forget sometimes. I have to clear it. There we go, before I can move on. All right, let's take a look at these next 4. Okay, so now we have graph E, F, G, and H. Now, some of these absolutely should be looking familiar to you. All right, next one. Maybe this one is not, but this one is f of x equals x cubed. This is the cubic function. Okay, we will be talking about that. Okay, but that's what it looks like. This one, everybody knows since 8th grade, you've been studying this. Y equals mx plus b, or linear functions. M is the slope and b is the starting point. Now, graph G might be a new one. It is called, its equation is f of x equals 1 over x, and that also translates to the reciprocal. I have sometimes trouble spelling, so be forewarned. There could be some serious spelling mistakes. And then I'm pretty sure this is every algebra student's favorite function family, the quadratic family, otherwise known as the quadratic function. We will dedicate an entire chapter to these guys. So that is f of x equals x squared. So again, your notes should look like mine. Have the name and the actual equation written there. Okay. All right. But that's a lot to remember, and we will discuss these, but there are really 3 that you're going to have to know for this first chapter. You're going to have to know them in and out. And so, oh, and I forgot to do it again, guys. I forgot to clear out my screen. Just give me a sec. All right, there we go. So you should be on the second page now. And one of the things that you have to know is you're going to have to know some pretty key characteristics. And you're going to have to be able to graph these with points. And so you're going to be using this thing called Desmos. And if you haven't used Desmos before, you have your Chromebook, pause the video here and go type into your web browser desmos.com. And when you get to desmos.com, you should see a screen that looks like this. Okay, it should look like kind of like a graphing calculator. Okay, and so the very first family of functions that we are going to graph is going to be the quadratic. So when you type this in, you just type in that left corner y equals x and then caret, which is shift 6, and that little cursor should go up, squared. Okay, now you will see off here to the right this plus minus sign, and you can zoom in or zoom out. On a lot of these, I'm going to zoom in or out because we're going to talk about some critical points. So right here, that is the vertex, critical point, and right here is a critical point. Ooh, we're going to do 1, 1, and right there is a critical point, and that's negative 1, 1. Why are they critical points? Well, because those are the next nice points. So what do I mean by nice? Well, I mean the next nice lattice point. There's an infinite number of points between these two, but I want one that lands right on that lattice of 1, 1 and negative 1, 1. So what does that mean, what we're going to do here? Well, in the end, this is what your graph should look like, okay? Except for in your notes, okay, this is what I would like you to think about. Okay, so we know that we have this graph right here. Okay, we have this point at 0, 0. There's our vertex. I'm going to mark that, and then you're going to come up 1 over 1. That's your next point. Okay, and then your next point was negative 1, negative 1, 1. So those are our 3 critical points. And now you can go ahead and draw in your U, or your quadratic. Please make sure you have those 3 points. If you just do something like this and say, there's my quadratic, I will not accept that. Either will Mr. Hogsett. You have to clearly mark these points because they become important here later on. Okay, so now I'm drawing on my screen, which is not very nice, but bear with me. Okay, so now I know that it goes through those points. Not so good. Let's see if I do a larger one. Will that look nicer? Kind of. Okay, and so that's the family that you need to know called the quadratic. Now here, I want you to be able to make some characteristics. Okay, so what do I mean by characteristics? Well, let's take a look at this graph. And there. Let's take a look at characteristics. Well, we know that it is U-shaped. We know that this points up. It has a vertex at 0, 0. Okay. Critical points at negative 1, 1 and 1, 1. Those are those kind of things that I want you to think about. Okay. All right. So stop your video. Make sure your notes are all filled in. Okay, let's go to the next one. Let's see what the next family is that you have to know. Okay, so the next family you have to know is going to be the square root. Okay, so let's go back to Desmos. Good old Desmos, okay? and I'm going to share my screen. When you're typing in the square root function into Desmos, you just type y equals sqrt, and then the square root symbol comes up, and x. And we already know what it looks like, so here it is. So first critical point is this guy. It's not really a vertex, okay? But that is the first critical point at 0, 0. Now, where is the next nice point, or the next nice lattice point? I go over, there it is. 1, 1. There we go. 1, 1. And if you want to keep going, if you want to put in a couple more, that's fine. 4, 2, 9, 3. Those are nice points. All right, so let's go back and put this into our notes. Okay, so we know our first point is here at 0, 0. So everybody put a point in at 0, 0, and then you're going to come up to 1, 1. Now, if you were like me, I sometimes need a little bit more help, so our next one was 4, 2, and then the next one was 9, 3. And we know we're just going to draw a nice line through that. Well, really more a curve. Let's see if I can do it. And it'll look something like that. Okay, characteristics. Well, characteristics, okay. It goes, we'll say starts at 0, 0. Critical point is going to be that 1, 1. Okay, it goes up and to the right. Right, and if we want to be very specific, the domain, we can add some of this fancy language. The domain goes from 0 to infinity, if we kept this line going. The range also goes from 0 to infinity. Ooh, I misspelled that one, didn't I? You guys didn't catch me. Okay. Lots of things that you can put for characteristics. If there are more characteristics that you want to put in there, please do so. Okay. If you have forgotten what domain and range mean, okay, domain right here and range right there, come see me and we'll clarify a few things. Okay, last one, guys. All right, last one for this video, and that is the absolute value function. And let's go back to Desmos and see what we can come up with. So when you go to Desmos, go to that top left, and you're going to type in y equals abs parentheses x, and there it is. It gives you that absolute value function. So again, let's find that vertex. It's a lot like the quadratic, except for it's V-shaped. Our first point, or our vertex, is 0, 0, and then take a look. Right there is going to be our nice point at 1, 1. If I can get right on it, there's 1, 1. And then here's the next point, negative 1, 1. Okay, those are the next nice points. Let's go put those in on our notes. Okay, it's not what I wanted. Okay, here we go. Let's put in our points. First point we know is down here, 0, 0. Then we're going to go negative 1, 1, and then 1, 1. And this time we know when we draw this, it's going to be straight lines through those 2 points. Okay, and it's going to be V-shaped. So there's one, and then there's the other. I'm going to redo this guy because it did not look very good. There we go. Okay, so that's what when I say put in the critical points, there's those 3 critical points. Let's type in some characteristics. Okay, it's V-shaped. Vertex is at 0, 0. critical points, -1, 1, and 1, 1. And you could keep going, but just those three. Let's do the domain. So the domain on this guy goes from -infinity to +infinity. And then what about the range? So the range, remember, really helps us to figure out what is, how tall the graph gets. It's in the y direction, and the range goes from 0. Notice it doesn't go below that. From this graph goes from 0 to infinity. If we kept the graph going, okay? That's only if we kept the graph going. All right, again, make sure your notes look like mine. Have all of the things written and have all of the graphs done by the time you come to your next class. And have a fabulous day, Algebra 3.